Hello, today and tomorrow we're going to be doing box and whisker plots. Today we're going to read box and whisker plots. A box and whisker plot is just a graph that summarizes a set of data by displaying it on a number line. It consists of three parts: a box, which is right there in the middle, okay, and two whiskers, okay, so like a cat. All right. Now, what they do with the difference in a box and whisker plot is that numbers are put in order and it's split up like a dollar bill. So you have quarters. Okay. The first whisker, okay, this whisker here is the first quarter of data, okay, just like you're having 25 cents. So it's the first quarter of the data. Okay. Then in here between the Q1 and Q2 is the second quarter of data. And then between Q2 and Q3 is the third quarter of data. And then the last whisker, okay, is the last quarter of data. So it's the top 25%. Okay? So split up in quarters, but more 25%. So between the minimum and Q1, you have 25% of the data. Between Q1 and Q2, you have 25% of the data. And then between Q2 and Q3, you have 25% of the data. And then between Q3 and the maximum, you have 25% of the data. The nice thing about box and whisker plots, if there's an outlier, okay, it's in the whiskers. Okay, it would either be the minimum number or the maximum number. Okay, the middle 50%, okay, right here, all right, is where obviously most of your data is and where you read the information. If you remember, the Q2 also says median, and we know how to find the median. You have to list the numbers in order, and the middle number is Q2. Q1 is the middle of the bottom half of numbers. Okay, so again, the numbers in order. Find the middle number between the median and the minimum. That'll give you Q1. And then Q3 is going to be the middle number between the median and the maximum. Okay. All right, let's talk a little bit about it. A little more. Okay, the box again is the median, and that's 50% of your data. It's the middle 50%. Okay, and it extends from the first quartile to the third quartile, and there's always a vertical line that represents the median, okay, or the Q2. Okay, again, it represents 50% of the data. So if we have these numbers, my middle number is 7. That is my Q2 or my median. Okay, all right, that's right there. Okay, now our other group, if I wanted to split this, okay, and find my median, it would be 5. Okay, and then over here, find my middle number, and it's 9. Okay, the box, okay, contains these numbers. Okay. And as you can see, if there's any outliers, okay, if 4 was a 0 or 10 was a 24, the box is not changed by an outlier. Okay. All right, the whiskers, okay, again, are the top 25%, which here would be your maximum. Okay, your Q3 to maximum. Okay, it's represents 25% of the data, and it's the top 25. This one, from the minimum to Q1, represents the bottom 25% of the data. Okay. All right, so let's look at two box and whisker plots, and let's compare them. All right, we're going to compare the average monthly rainfall for each city. And what we're going to use is what's called the Interquartile Range, IQR. Okay, and what it is the box of the box and whisker plot graph. Okay, so we're going to look at the middle 50%. Okay, so the middle 50%. So we don't care about the bottom 25% or the top 25%. It's the middle 50%. Okay, so if you notice, the box for Miami is longer. So Miami has a greater interquartile range. New Orleans, it's smaller, okay, so it has a smaller interquartile range. Okay, the greater range means that 50% of Miami's monthly rainfall varies more because its rainfall varied from about 2.5 inches to 7 inches. Okay, New Orleans Interquartile Range went from about 5 inches to 6 inches. So it varied an inch. 50% of the data only varied an inch, where in Miami, 50% of the data went from 2.5 inches to 7 inches. So it had a greater variance in that 50%. Okay? And that's a conclusion we can make based off looking at the two graphs. Okay? All right, let's look at the next one, arm spans. So we have Class A and Class B, and we want to compare the data. So we always look at the box. Okay? Class A's arm span went from 63 to about 67. Okay. Class B went from about 62.5 to 68. Okay. So our conclusion, because Class B has a wider range in their box, was that their middle 50% or their interquartile range had a greater variance. Okay, the numbers were farther apart in the 50%, where Class A, the numbers were closer together. Another thing we can look at is the range. Class A's range went from 72 down to 60. So it had a range of 12. Class B went from 70 to about 61. So it had a range of 11. Okay. So Class A's range is longer or broader than Class B. Okay. All right, let's look at another one with cereal boxes. Okay. All right, a cereal company is choosing between two devices to package their cereal into. The box and whisker plot shows the weights of the bags packed by each device. So device 1, okay, you can look, it has a range, right? And then device 2. It says which device produces packages with a more consistent weight, okay? So a more consistent weight would be a smaller range. So device 1, okay, has a range of about 17.4 as the high and 16.7, okay, which gives us a difference of 0.7. Device 2 has a range of about 17.7 as high and low about 16.6. So its range is about 1.1 ounces. Okay, so if we wanted a more consistent device to package, we would pick package 1 or device 1 because the range is smaller. There's not as many outliers or a greater difference in the size of the packaging. B asks which device should be chosen if the manufacturer wants to minimize the number of packages that weigh less than 17 ounces. Okay, so let's take a look at this. So here's 17 ounces on our graph. Okay, now we want to minimize the number of packages 17 ounces. So you can see device 1 has a whisker. Okay, that's 25% of the data. And it also has part of the box, which is part of another 25% of the data. So it has over 25% of its packaging less than 17 ounces. So let's look at device 2. Device 2, okay, 17 is about right there. It has 25% of its packaging below 17 ounces. Okay, so it only has 25% of the packages below 17 ounces. So that's fewer than device 1. Okay, so if we want a device that's going to produce less than 17 ounces, fewer weights, less than 17 ounces, it would be device 2. Okay. The next one asks which device should be chosen if the manufacturer wants to have more than 17 ounces. Okay, 17.2 ounces. So here is 17.2 ounces. Okay, if we look at device 1, it has 25% of its data greater than 17.2 ounces. Okay, if we look at device 2, we follow that down, and it has over 50% greater, okay, than 17.2 ounces. Okay, so we would pick device 1. Okay, device 1 has fewer numbers, more than 17.2 ounces. Okay, because it only has 25% of its packaging greater than 17.2 ounces, where device 2 has over 50%.